Okay, the last portion of this section, 4.4, this is really important for you to grasp the idea. Something that we're going to be using all throughout. You need to separate between what do they mean by integrate, what do they mean by area. And you need to use the integral as a tool to really distinguish and find those two. So I'll start with an example, number 48. It says, the current in a wire is defined as the derivative of the charge, right there. What does the integral from a to b of I of t dt equal? That's the integral from a to b, and I of t is the rate of change of the current. When we integrated velocity, do you remember what we got? The distance. Provided what? Provided the velocity was positive. So when I say this is the net charge between time equal a and time equal b, I can't multitask, between t equal a, whatever a is, and t equal b. So what does net mean? Let's get that out of the way, because that's something this section touches on, and it comes up all over the place every time you're integrating. So this is for applications. Net means the overall. So I really need to separate between two things. If I was at a point and I moved east 5 units and I moved west 3 units, if I integrate this function, right? If I take the integral of this function, whatever that is, f of t, if I integrate f of t dt, right? And if I integrated all the way, let's say that took me 8 units, from 0 to 8. The integral will say this is 2. And how is that? Well, it'll figure that you moved forward 5, you moved backwards 3. With reference to where you started, you are 2 units away. East in this case. But if I wanted to know how many steps I really went over, well, we have an easy fix. Meaning the area. We slap an absolute value on this. That would be the 5 plus the 3. That would be an 8. Here, that would be the 5. That would be a 2. So, if I was to walk into a casino in Vegas, and if I was to spend $500, and if I was to win $30,000, so as I'm playing, I spent $500, I end up winning $30,000. If I was to gamble all of that back, if I was to gamble with the $30,000 total, and I leave, somebody will ask me, hey, so how was your trip to the casino? I could say, well, I lost $500. If you integrate, right, the integral itself will say minus 500. You went in, you lost $500, you came out, compared to where you started with, the amount of money. Versus, if you put an absolute value, it'll say you lost $30,500. You really spend the $500, but you also spend the $30,000. So, the integral tells you overall where you stand. An absolute value pretty much sums up everything. Alright? So the next problem is number 56, and you have to distinguish between those. And let's start with this problem. It says the velocity function in meters per second is given for a particle moving along a line. Find the displacement. Displacement means, well, if I started at point A, right, let's say I started in Pasadena, and I moved east on the freeway, then went west, then back east, then back west. Displacement simply means, with respect to where you started, where are you right now? That's all that matters. Versus total distance will be like the odometer on your car, whether you're going east or west, it doesn't distinguish between that. As the wheel turns forward or backward, that mileage is added up. So in part A, I'm simply looking for the integral from 2 to 4 of t squared minus 2t minus 3 dt. So if I see on the exam setup do not solve, that's all I want. Versus, if I really look at part B says find the distance traveled. It looks the same. Most of the work is the same, with one minor exception. And that minor exception turns up to have a massive effect. So this is really t cubed over 3 minus t squared minus 3t evaluated from 2 to 4. That is 64 over 3 minus 16 minus 12. And if I put a 2 in there, that will be 8/3 minus 4 minus 6. Altogether, we're talking about 64 over 3 minus 28 minus 8/3 plus 10. So altogether, we're talking about 64 minus 8. That's 56 over 3 minus 18. So altogether over 3, that is 3 times 54. 56 minus 54, 2/3 of a meter. 0.6 meters, less than a meter away. When I get to part B, well, we have a small, tiny problem. Absolute value. How do you split absolute value? Either you graph it or you do testing. If I look at this, I'm looking at, remember I showed you how to graph all absolute values. How do you graph t squared minus 2t minus 3? Well, that's t minus 3 into t plus 2, if you recall. So it has an intercept at 3 and at -2. And since parabola opens up, it looks something like this. And when we said if you slap an absolute value on it, do you remember how that works? It takes the negative and reject it or transform that to the positive. It really makes the graph look something like this. Well, the bottom line is you only need to know that the graph looks like this. And if I'm looking from 2, x equal 2 to x equal 4, so let me extend that a bit. Again, a rough sketch will do as long as the algebra matches. I'm really looking for those. So obviously in the beginning you were going backwards. Well, what matters is this is going to be the integral from 2 to, and that's the point that matters, to 3. I don't need the absolute value anymore because I can't integrate with it. But what's the price for dropping the absolute value? Since this is below the x-axis, if it says find the area or the distance traveled, that's negative. And wherever the absolute value is positive, it's really not changing much. That's a 3. It's really, the sign is not changing. It's positive, so I really don't need the absolute value. And pretty much this simply becomes a problem of just, we already did this. We know what that is. That is t cubed over 3 minus t squared minus 3t evaluated from 2 to 3 plus the same deal again. That turns out to be negative 3. 27 over 3 is a 9. Minus 9. Oh hey, many 9s. 2 8/3 minus 4 minus 6. Right? So those cancel out. That's a 9. And this negative will cancel that negative. Plus 8/3 minus 10. Alright. And this right here is going to be a 4 in there. That's 64 over 3 minus 16 minus 12 minus a 3 in there. We just put a 3. It's right there. That is a... So a 9 minus 9 minus 9. Those will cancel as well. That will be a positive 9. And those cancel. That's 8/3 minus 10. And that would be 64 over 3 minus 28 plus 9. So I'm looking at a negative 38. And I'm looking at 64, 72 over the 24. 24 plus 18, whatever that is. 42. That turns out to be 4 meters. Altogether, we moved backwards and forward a total of 4 meters. Oh yeah, by the way, on a test, this is a fine answer. Make sure to put the units at the end. I insist on that. You don't have to drag the units with you, but I want the units at the end. And we're looking at this a bit differently, the same deal. The acceleration of a function in meters per second squared and initial velocity are given for a particle. There's the acceleration, there's the velocity. A. Find the velocity at time t. Find the velocity at time t. Well, that's simply velocity is nothing more than the integral from 0, the integral velocity, let's say from 0 to 3, of a of t dt. And that turns out to be the integral of 2t plus 3 dt. That's an a. And that would be a t squared plus 3t plus c. You know the drill, since this is an initial value problem. I would say the velocity will be negative 4 when t is 0. And that's how I find c. C turns out to be a negative 4. So this is a negative 4. I got the velocity function to be t squared plus 3t minus 4. That's part A. In part B, it states, find the distance. Distance is going to be the integral from 0 to 3 of the velocity function. And the same game is played again. Since I want this, you have two options. Option is to graph it. That's faster. Or to make a line. Either way, you need to factor that. Either way, you're going to need to say, well, that is t plus 4 into t minus 1 equal to 0. So t is at 1, and at negative 1, negative 2, negative 3, and negative 4. So it's a parabola that looks like that, right? Or you could do test points. You could put the 1 there, the negative 4 there, pick a point right there, a point right there, and a point right there, whatever works. And I'm looking at this from 0 specifically to 3. So if I extend this, I'm really looking at this region and this region. So that's going to be negative the integral from 0 to 1 of t squared plus 3t minus 4 dt plus the integral from 1 to 3 again. If the absolute value, if the inside of the absolute value is positive, I don't need the absolute value. And this is going to be a negative t cubed over 3 plus 3t squared over 2 minus 4t evaluated from 0 to 1 plus t cubed over 3 plus 3t squared over 2 minus 4t evaluated. And that would be negative 1/3 plus 3/2 minus 4. If you put a 0, you're going to get a 0. Plus 9 plus 27/2. 27/2 minus 12 minus a 1/3 plus 3/2 minus a 4. And again, you could box that on the homework, you work it out, and you could put that in meters. That